Welcome to problem number 10 of the 2025 AIME 1 problem series. So in problem 10, we are told that the 27 cells of a 3 by 9 grid are filled in using the numbers 1 through 9 so that each row contains 9 different numbers in each of the 3 by 3 blocks heavily outlined in the example contains 9 different numbers as in the first 3 rows of a Sudoku puzzle. The number of different ways to fill such a grid can be written as this prime factorization, where P, Q, R, and S are distinct prime numbers, and A, B, C, and D are positive integers. And we want to find the complicated sum down below. So essentially, we are just asked to find the number of total ways to make this possible, to actually fill this Sudoku puzzle out. So what I have here drawn is a box that we can use to model our choices. So what we can do is we can essentially begin with the top row. And so for the top row, the number of total possible ways to put the numbers 1 through 9 in the top row is simply going to be 9 factorial. If we have to arrange numbers 1 through 9, and it really doesn't matter what order we arrange them with or how we arrange them in terms of grouping, we can arrange them the way we want to. So say I put here 5, 3, 6, 1, 2, 9, and then 7, 8, and 4. So this is something that I could have done. Okay, well, now let's consider the number of ways to do the second row. So with the second row, we actually have to start going into casework for the reason being that depending on how many numbers in this over here, in this area over here, we have grouped together in the second row, we will have different numbers of total outcomes. So let me explain. Say for case one that the numbers 5, 3, and 6, right, are first top three numbers. So I'm just going to call that group like X. So say X stays together. Say X stays together. Well, in that case, 5, 3, 6 is either going to go right here or right here because it definitely cannot go here, because these will be in the same square. So there are two different ways to decide which group X goes to. So that's 2 times the number of ways to arrange it in that group, which is going to be 3 factorial. So we have 2 times 3 factorial. And then, so say we put 5, 3, and 6 in this spot over here. 5, 3, and actually we can arrange the order. So I'm going to put 5, 6, and 3. Well, here, 1, 2, and 9 have to stay together as well. And as a matter of fact, they actually have to go here because if they split up, then one of 7, 8, or 4, or one or more of 7, 8, and 4 have to come back in this own square, and that is going to violate this condition. So 1, 2, and 8, 1, 2, and 9 must also go to this group. So given that there are 3 factorial ways to arrange 1, 2, and 9, and then there are 3 factorial ways to arrange 7, 8, and 4 in this group over here. So that is the case if 5, 6, and 3 stay together. Now, if 5, 6, and 3 don't stay together, so say 5 and 3 stay together and 6 goes here. So they split up. So case 2 will be that they split up, right? And here I'm going to just simplify this a bit. So 3 factorial is 6. Another way of writing this is 2 times 6 to the third. So if x splits up, what we can write is that 1, 2, and 9, these three numbers must also split up. Because if they stay together, if they all go to this group over here, then 1 of 7, 8, or 4, sorry, 2 of 7, 8, and 4 will have to come here, and that is going to be a violation. So essentially, we have to pick two numbers out of 1, 2, and 9 to go in these two spots. So that's just going to be 3, choose 2 ways to pick. And once we pick the numbers that go here, there's going to be 6 or 3 factorial or 6 ways to arrange these 3 numbers in this group. So we have 3 factorial. And it's probably important to go ahead and write, before we forget, the number of total ways that we could have arranged 5, 3, and 6 if we were to split them up. So if we were to split them up with 2 of 5, 3, and 6 being in this group, and one of the numbers being in this group over here, then that is going to be 3 ways to do that, since there's only 3 ways to pick the number that goes in this right group. And say if we were to pick one number to be in this group and then 2 numbers to be in this group, well, then that would be another 3 ways. So that's a total of 3 plus 3 or 6 ways, without regard to arranging it in each of the groups. So without regard to putting 6 here, here, or here, we're just talking about the number of ways to split it up. So there's 6 total ways to split it up. That's why we're multiplying by 6 here. Okay, so now that we've picked this, what we can go ahead and do is, so say we pick 1 and 9 to go here. Well, now we have to write 2, 7, 8, and 4 in each of these. So obviously 2 will have to go here somewhere. We don't know exactly where, but let's say it goes here. Because it definitely cannot go in this spot over here. So we have to put 7, 8, and 4 in these gaps, and really it doesn't matter how we do it. Now, there are going to be, oops, this is going to take a while, but there are going to be 3 choose 2 ways to pick 2 numbers that go in the column with the 2. So 3 choose 2, or that go in the group with 2. And then in that group with 2, there's going to be 3 factorial ways to arrange those 3 numbers. And when we pick, so say we pick 7 and 4 to go here, right? There's going to be 3 choose 2 ways to pick the 7 and 4, and then 3 factorial ways to arrange 7, 2, and 4. So in this case, it happens to be 7, 2, then 4. Then that leaves 8 to go right here. And then obviously there's 3 factorial ways to arrange this middle group. So we multiply at the end by 3 factorial. And this gives us, well, 6 times 3 choose 2 times 3 choose 2, 6 times 3, which happens to be 54 times 3 factorial cubed, or times 6 cubed. Okay, so those are really the only 2 conditions that we have here, depending on whether x splits up or stays together. And remember, we defined x as being this over here, this top left group. Okay, so the total number for case 2, the total ways to fill out the second row after filling out the first row is going to be 56 times 6 to the third. And then lastly, we just have to fill out the number of ways in the bottom row. And so in this case, 5, 3, 6, 7, 2, 4, we know that 1, 2, and 9 have to go here. Or sorry, 1, 4, or 1, 8, and 9. Yeah, we know that 1, 8, and 9 have to go here. So after filling out each of the first 6 in each square, there's obviously only 3 ways for each of them. And since there's 3 numbers to put in each of these groups or in each of these squares, there's going to be 3 factorial ways to arrange them, and that's 6 per square. So we have 6 cubed ways to arrange the total last ones. So in this case, we would have to put 7, um, 4, and I think it's 7, 4, and 6 here in any order, 3 factorial ways. And then here we would have to put 2, 5, and 3 here, and then 3 factorial ways to do that. So now this is the total number for each of the rows, and now we can simply go ahead and multiply these up. So we have to find 9 factorial times 56 times 6 cubed times 6 cubed. We can go ahead and start prime factorizing now, since at the end, that's what the form of our answer is going to be like. So 9 factorial, I can just go ahead and write that to the side. We know that 9 factorial is equal to 9, 3 squared, times 8, 2 cubed, times 7, times 6, times 5, times 4, times 3, times 2, times 1. So here we see that the total number of 2's is 7, total number of 3's is 4, and then we have 1, 5, and 1, 7. So we know that this over here equals 2 to the 7th times 3 to the 4th times 5 times 7. And then 56 is obviously just going to be 7 times 8, or 7 times 2 cubed. And then 6 is 2 times 3. So 6 to the third times 6 to the third is 6 to the sixth. And 6 to the sixth is 2 to the sixth times 3 to the sixth. So we just combined these two over here. Okay, and now we can go ahead and simplify it from here. So we have 2 to the 7th times 2 to the third times 2 to the sixth, which happens to be 2 to the 16th, I think. 2 to the 16th. Then we have 3 to the 4th times 3 to the 6th, which happens to be 3 to the 10th. Then we have 5, and then we have 7 squared. I'm going to write this as 5 to the first. And now here, we just have to find p times a, so 2 times 16, plus 3 times 10, plus 5 times 1, times 7 times 2, plus 7 times 2. So 2 times 16, plus 3 times 10, plus 5 times 1, plus 7 times 2 is going to be equal to 32 plus 30 plus 5 plus 14. Okay, that's going to be equal to 32 plus 30 is 62, plus 5 is 67, plus 14 gives us our very final answer of 81. Okay, and that is the solution for the 2025 AIME 1 problem 10. So thank you for watching, and thanks for sticking along to this playlist of the first 10 AIME problems. And please go ahead and like, subscribe, comment down below if you have any questions. I'll be happy to get to them later. Thank you.